This is a video about how to do math with the ideal gas law. In an earlier video, we went through the origin of this formula. That formula is known as the ideal gas law. The reason it's called an ideal gas law is because it only applies to ideal gases. So just on the side here, if a gas is ideal, they don't attract each other. In other words, if you have 100 molecules or 1,000,000 molecules or 1,000,000,000,000 molecules in a container, we would say that none of the molecules attract each other. That's not really true because we know that there are attractions between molecules, but the attractions for gases are minimal, so we just assume that they don't attract each other. And the other assumption about an ideal gas is that the molecules themselves don't occupy space. And of course they do occupy a little bit of space. But as gases, we assume that they do not to make our laws work. So this is really for ideal gases. It's important to know that if a substance is a gas, it approaches ideal behavior. And if the higher the temperature is, the more ideal it is, as well as the lower the pressure. Because a high temperature and a low pressure would minimize the attractions between the molecules. All right, so with all that being said, let's just do a problem or two here. We'll do number 8. So how many milliliters of nitrogen would need to be collected? 99.19 kPa's and 28 degrees C to have a sample containing 0.015 moles of nitrogen. So you look for numbers to plug into the equation. So the pressure, well, you remember from the pressure video, kilopascals measures pressure. So pressure would be 99.19 kPa. Volume, we're looking for that because we want to know how many milliliters. You might notice this little worksheet that I pulled off the internet was probably created in England because of the way they spelled liter. That's volume. The number of moles, 0.015, it tells us right here. So N is 0.015 moles. R, since the pressure is measured in kilopascals, we're going to use the value for R that matches that. Now you remember I gave you two values of R. One was 0.08205, or I think I said 0.0821, and that's liter atmospheres per mole Kelvin. The other one that I gave you was 8.31, and that was liter kilopascals per mole Kelvin. So I need to put in for R the one that matches with kilopascals, which is 8.31 liter kilopascals per mole Kelvin. I'm going to do this one with a complete showing of the units so that you can see how they cancel out. And the temperature is 28 degrees C, but remember we can't use C in gas law problems. So we have to change our C into K by adding 273. So I add them together here, you get an 11, you get a 1, you get 801, so you get 301 would be our temperature in K. Okay, now you'll notice that the kelvins cancel and the moles cancel. So when I work this out, and I'm going to go ahead and do that on the side, you won't be able to see, well, yeah, you will be able to see it too. Forgot I'm not doing a video meeting, I'm doing a video recording. So there's a calculator. I'm going to take 0.015, I'm going to multiply by 8.31, I'm going to multiply that by 301, and end up with 37.5, I just call it 37.5. The units would be liter kilopascals. On this side, I've got 99.19 kPa's times volume. So I need to solve for volume. To do that, I need to get rid of this number. Notice that this number is multiplied by volume, not added to it. So we need to divide both sides by the number that is with the variable. So 99.19, 99.19, and that's kilopascals, and that's kilopascals. I forgot to put the P in there. Okay, so now the number cancels, the kilopascals cancel. I'm left with volume on that side. On the other side, I've got 37.5 divided by 99.19, 0.378. And kilopascals have canceled, so it's 0.378 liters. And that's how you solve for volume. We might notice that it asks for milliliters. So then I would need to get my final answer, I'd change liters to milliliters. So liters here, milliliters here. One thing is 1,000 millithings. So 378 milliliters. And that would be our final answer. So that's as hard as they're going to get initially. There are, of course, some higher levels that you could do, but I think I'll make sure we're good on these before I make a video about the higher level ones. So I think I'll stop here. That's how you do a P equals nRT. Basically, it's just you write the formula down, you put in the numbers, and you solve for what you don't know. Just what I always call a plug and chug kind of problem.